this woman, and I need to get energy. But how?
I am Nuclear Man, and I have come to save the day.
Yay, Nuclear Man! Thank you. You're my hero.
Oh, it's nothing. This is my duty.
How will I ever repay you?
With nothing, of course. Your reward is an education.
On what? How to make cookies? Pizza?
Of course not. On nuclear energy.
Like, OMG, are you serious?
Yes. Are you ready?
Let's get ready to rumble! In a scientific manner, of course.
Our first lesson today is on nuclear fusion and nuclear fission. In nuclear fusion, two atoms combine together to create one. This releases energy. One. In nuclear fission, two atoms break apart to create two smaller atoms.
This is so fascinating. Please tell me there's more.
Of course. Let's go inside. Yes.
Are nuclear reactions anything like chemical reactions? Because I know lots about chemical reactions.
I'm sorry, but that knowledge will not work here. You see, chemical reactions are totally independent of nuclear reactions.
Oh, tell me more.
Well, as I'm sure you already know, chemical reactions involve an atom's electrons. In a nuclear reaction, the nucleus of an atom is utilized.
Okay, but why would we use nuclear reactions instead of chemical ones?
Ah, very good question. Well, when a chemical reaction takes place, two atoms' outermost electrons are rearranged. This does not give off a lot of energy.
And what about nuclear reactions?
Well, in those, the nuclei of the atoms are involved, and they actually change into different elements. This produces a lot more energy than in chemical reactions. For some nuclear reactions to happen, the atoms must be bombarded with large amounts of energy.
Ooh, a diagram.
You see, in chemical reactions, atoms undergo changes and create new chemicals. The electrons participate, not the nuclei, and the elements don't change. What goes in must come out. Also, small amounts of energy are absorbed, no radioactivity can be given off, and it can be reversed. Now, in nuclear reactions, the nucleus undergoes a change, the identity of the element changes, and large amounts of energy are absorbed. It is accompanied by strong radioactive emissions, and is not affected by temperature or pressure. It cannot be reversed.
I get it now. But what about radioactivity?
Well, do you understand the root of radioactivity?
I guess not.
Well, it all has to do with atoms. You see, an atom is a specific element by the number of protons it has. The number of electrons can change. Atoms that don't have the same number of electrons and protons are called isotopes.
Oh, yeah. I know about all this from science.
Well, what you may not know is that there are some isotopes that are radioactive. These are isotopes that will spontaneously break down into another isotope. Potassium is a wonderful example of this. There's a radioactive isotope of potassium called potassium-40 that decays into the stable atom, potassium-39.
Oh, I think I get it now. Anyway, is there any other reason for us to care about all this nuclear stuff? I mean, does it like turn seeds into plants in 10 seconds flat?
Well, not quite that far, but radioisotopes are used in a variety of ways. For example, they're used in medicine to detect and diagnose diseases, and are also used to help with cancer because of their radioactivity.
So I was kind of right.
Yeah, I guess you could say that. Radioisotopes also used in plenty of other businesses too.
Oh, do tell.
Well, on second thought, there are more uses of them in the medical world, mainly sterilizing medical implements and such. They're used in the food industry for much of the same reason, to help keep food from going bad. They're also used in the agricultural industry to kill pests and bacterium that can harm crops.
Wow, I never knew they could help us so much.
Yes, they do, but they can also be dangerous.
Wait, dangerous? I thought you just said they were so helpful.
Well, nothing's perfect. Now, do you want me to explain, or are you just going to keep arguing with me?
Explain, please.
Well, How harmful the radiation is all depends on how the isotope decays. When an isotope decays, the radiation is given off in rays. There are alpha, beta, and gamma rays. Each has its own properties and level of harm. However, every one of them does the same basic thing to human body cells. When the ray hits them, an electron is sent shooting out of its shell, causing problems, and usually cell death or genetic mutation. Now, the weakest alpha rays consist of alpha particles. These are combinations of 2 protons and 2 neutrons that are bound together. Alpha particles are not a threat to the outside of your body because they're too big to penetrate it. If you ingest an atom with alpha particles in it, however, that can be very dangerous to your health. These rays can be helpful in weaponry.
I see. Did you say that there were 2 more kinds of these rays?
Yes, indeed there are. Beta rays are made up of beta particles, which are just electrons thrown off the nucleus during beta decay. These can penetrate a little deeper than alpha particles, but are only truly dangerous if they're ingested like alpha particles. Now the final gamma rays can be caused by both beta and alpha decay. What they are extra energy given off by atoms in a single burst. Since they are made of energy that can penetrate very deeply and are only able to be stopped by lead, they have potential to help with cancer.
So, does this mean I should go around wearing a lead suit all day to protect myself?
No need for that. You see, the majority of these rays are given off from the sun or other stars. When these rays come into contact with rays in our atmosphere, they get messed up and a much weaker ray comes down to Earth and us humans. Hello? I must leave. Sorry, I was saving this kitten. Okay, anyways, back on topic.
What's actually going on inside the atom thinger to make all this happen?
Well, in fission, it's a very intricate process. You see, in a radioactive heavy isotope, the strong force and the electromagnetic force are in equilibrium. The strong force is the force that keeps 2 atoms together, and the electromagnetic force is the force that makes 2 like charges repel. Now, when a proton or neutron is absorbed, it throws this balance out of whack. In an attempt to regain equilibrium, the atom moves back and forth. Eventually, the electromagnetic force overcomes the strong force, and the atom flies apart.
Thank you so much, Nuclear Man. Now I really understand how nuclear energy works.
It's all in a day's work.
But how can I use this knowledge to get the energy I need?
Get active in your community, start telling people about the benefits of nuclear power.
Wait! Will I ever see you again?
You might. I go where people need energy. If you ever need me, just yell out, Nuclear!